Hi, my name's Anthony on the Bicep engineering team. Today I wanted to introduce a new capability we've built for Bicep as an experimental feature that's called Bicep Snapshot, and that's going to be available in the upcoming Bicep 0.36 release. So for those of you unfamiliar with snapshot testing, I think one challenge that people often face when working with very complicated Bicep infrastructure deployments is that, to accomplish some refactoring, you often need to do you often need to touch a lot of different files. You have your Bicep parameters file, you have your kind of complex set of modules, and you're often kind of taking values, modifying them, passing them down, using expressions, and it can become a little unclear sometimes, I think, where, this value being changed in this Bicep parameter, how does it actually interact with this module, like, 4 nested modules deep? Does it actually accomplish the thing I thought it was going to, or did I make a mistake somewhere? So Bicep Snapshot, the idea here is that we basically create a normalized view of all of the resources in my deployment. We resolve as many of those expressions as we can. And so here's an example of the format that it generates. The actual file itself is not really something that we expect users to interact with too much. So the real kind of main goal here is that it's a normalized view of resources. It's good for diffing. It doesn't change with, it's resilient to refactoring. So if you move a resource from one Bicep file to another, as long as the actual resource contents are the same, that shouldn't result in a diff in the snapshot. And the reasons for that are that we want, it's kind of intentional that we want these snapshots to be easy to kind of look at and see if, a change has been made to the infrastructure file, then what is the actual impact on the snapshot itself? So they should work well with tools like git diff or code review tools. So just to demonstrate the capabilities, I've got a couple of bash scripts I created. These are really just wrappers around the Bicep snapshot CLI command. I've got snap validate, which is calling Bicep snapshot with mode validate. And I've got Bicep snapshot without mode validate, which is going to overwrite the snapshot. Validate is actually going to create a new snapshot, compare it to the one here checked in, and if the two are the same, it's going to log snapshot validation successful. If there are any differences, it's going to show me the differences, and it's going to tell me that the validation failed. One thing to note that's interesting is I'm passing in my subscription ID, and I'm passing in a resource group name. I'm passing in the location. All of these things are useful for generating the snapshot because, it gives me more concrete information about the resources that are going to be deployed. So it gives me the actual resource ID in full rather than kind of leaving variables in place. So let's go ahead and run those bash scripts. First of all, let's run snap validate. This should tell me there are no changes. So snapshot validation successful. It logs a bunch of warnings about Bicep diagnostics. Snap overwrite, again, not particularly interesting right now because it should just generate the exact same snapshot because my snapshot is updated. So just to give you an idea of how this could be used, I've got some changes stashed. So this is kind of, pretending I'm a developer who has made a set of changes across various different infrastructure files. In this case, what I'm doing is simulating, enabling, making my zone redundancy configurable and enabling zone redundancy in prod and having a test environment where zone redundancy is disabled. Often it's convenient to save money by not having zone redundant resources in places where you don't need them, such as your test environment. So this is just an example of like a typical change that someone might make to their infrastructure files. I think what is challenging here is that, because of the amount of modules involved, I'm renaming, I'm changing the kind of usage of parameters. And so looking over the diff, it's not necessarily obvious to the person reviewing that, this is all going to result in the intended effect, which is in prod, zone redundancy is enabled. So now let's try, now that I have all these changes made, one thing you'll notice is my snapshot I haven't changed. So I've gone and made all my infrastructure changes, but I haven't yet updated the snapshot. So let's run snap validate now to see what happens. So now we are able to generate a new snapshot, and we know that the snapshot is different to the one that's been checked in. And so here our snapshot validation fails because we saw changes that we weren't expecting. And for convenience, we also kind of log the actual changes themselves in a what if like format, just to make it kind of really easy to visualize what's changing. So this tells me that we saw some unexpected changes. We saw these zones being added to this particular resource. The SKU capacity was increased from 1 to 3. This particular resource, the Cosmos DB account, was made zone redundant. And so looking at this, like, it's pretty clear to me that these are the changes I was expecting. There's nothing else that's changed that was unexpected. So as a developer, I can now run bash snapshot overwrite, which is just going to go and update that snapshot with the latest changes. So that's the kind of local developments use case for it. To give an example of how it could be useful in reviews, I'll switch to the GitHub repo I created for this. I've got 2 examples of pull requests, one of which where the developer remembered to update their snapshots, and one of which where the developer didn't remember to update their snapshots. So first of all, let's look at the example where the developer didn't update snapshots. So we have a set of infra file changes. There are no changes to the snapshot file. Because I have, if we go look at our GitHub workflow here, because I've configured this Bicep snapshot tool to run here, this is basically going to fail the CI checks if any of those snapshots are different. So here my check has failed. If I'm the developer or if I'm someone reviewing this code, it's pretty clear to me that something isn't right. And I can go look at the output of this command, and I can go see, like, this is exactly, what was missing from the PR. So I can see that basically the developer made a set of changes, but didn't actually check in the snapshot to validate what changes were being made. And then finally, if we go look at, an example where the developer has checked in the snapshot, as a reviewer, it's pretty clear that everything is passing, the check is green, and I can now go and look at the snapshot. And so here's where I think the benefit of this format comes in. I can see very clearly as the reviewer exactly what has changed. I can see, I'm not looking at modules, and I'm not looking at, variables. I'm looking at actual concrete values, and I'm looking at resource IDs. So I can see for this resource ID here, this Cosmos DB account, zone redundancy has been enabled. I can see for this API management resource, the SKU capacity has been increased. So as a reviewer, this just gives me an extra level of confidence that, even though everything looks right in the Bicep param and the Bicep files themselves, I'm able to actually verify, like, these are the actual changes that are going to occur to the resources in my Azure subscription as a result of deploying. So that was a very quick overview of snapshot testing in Bicep. Like I said, it's going to be available in the upcoming Bicep 0.36 release as an experimental feature. So you should be able to access that yourself as soon as it's available. I think right now it's fairly speculative, and so I'm interested in hearing feedback on where people find this useful or if people don't find it useful. So please try it out and give me your feedback. I will say that for some of the more complicated sets of deployments we have on my team in particular, we find, we have kind of similar capabilities with baselines that we generate for infrastructure changes. And we found that extremely useful for just being able to have confidence that these kind of complex changes in production are going to occur the way that we thought they were. Thanks, that's all I had.